My name is Neal Shrader, software engineer here at DigitalOcean. I've been working on DigitalOcean since about 2012 or so, but I've been working with the same group of guys for quite some time. So it's been an interesting little journey along here. Things have changed quite a bit. You can reach me by email. I encourage you to reach out and say hello. And my Twitter handle is icosahedral, and maybe should change that at some point, but that's how you can reach me. So I'll dive right in. Why FreeBSD? FreeBSD is an excellent operating system. It's stable, it's well engineered. Unlike a lot of the Linux projects, the entire project is driven by a single organization, the FreeBSD group, handling the kernel, drivers, and user space utilities core to the operating system, and are held to a very high, consistent standard. And one of the things that attracts us, particularly as DigitalOcean, to FreeBSD is the excellent documentation that the FreeBSD project offers. All of the docs, the man pages, are available on the system itself, so it's very easy to access. And if you haven't seen it, I highly recommend looking at the FreeBSD handbook. At some point or another while navigating FreeBSD, you'll probably land on it. It's a phenomenal and exhaustive piece of technical documentation that covers the operating system well, and I highly encourage everyone to take a look at it. And also, it was the second highest user voice request on our platform for quite some time. Thousands of people wanted this. So that begs the question, what took so long? And that's a fair one. So there are two bits here. One, the technical foundation in order for us to actually offer the image. We needed to address some things in our backend code to be able to actually ship this thing. And the project and product focus. And I'll focus on each of these separately with a bit of a dive. So let's talk image customization. Image customization is just simply the thing that makes your droplet, gives the droplet its identity. The things like hostname, SSH key, network configuration. There's anything that differentiates it just from the vanilla image that is presented. We at DigitalOcean, we have our own in-house backend that we use to launch us into production. And this old-style image customization, unfortunately, was very tightly coupled to the actual images themselves. The mechanism that this code base used was essentially it took a vanilla image and it mounted it on a loopback, and then it wrote hostname SSH keys directly into it. The unfortunate thing about that is that required a lot of knowledge of what was actually internal to the image. And it made a lot of assumptions about what the file system, the expected file system. And in the context of FreeBSD, writing to UFS from a Linux host, while reading it is fine, the kernel basically states danger, danger if you actually try to write to it from a Linux host. So that's why we shied away from actually doing this with this old code, essentially. The other bit is, at DigitalOcean, we have external kernel management. When it was initially being written, the assumption was that it would be easier to offer a base raw disk that didn't have a partition table. And that would be easier to scale up and down if it was just a raw disk with a file system. In order to do that, we were using KVM. And you need to present an NRD and kernel externally to the KVM process in order to make it launch properly. In the case of FreeBSD, FreeBSD is not Linux. So that's a very straightforward problem. So those were some of the challenges that we were facing when we were catching up with our growth, as it were. And then along came CoreOS. CoreOS is a unique Linux distribution in that it's meant to be easily clustered. It's meant to manage essentially Docker containers dynamically. It has two things that we needed to be able to support in order to offer it. One, its update mechanism is an active-passive partition. So the running partition, whenever there's an update to the CoreOS system, happens to the one that's not active at that time. And then when it's ready, it just reboots and pops into that. So it's a very quick mechanism. Requires a partition table. obviously. And CoreOS also, when you're launching the instances, in order to dynamically cluster them, you need to be able to feed information about itself to its Cloud Init configuration so that they can come together with minimal intervention on our side. In order to make that happen, we need a service that can tell the droplet about itself. And this is so simple, but it's one of my favorite little things that we have here. So metadata, all it is it's a small little HTTP service that gives information about the droplet on the link local. So 169.254, 169.254. You query down and you can get information about the droplet ID, SSH keys, hostname, network config, all of that stuff. And it's not necessarily complex, but the power is in when that information arrives, not necessarily what it is. So this metadata service has all of the information to provide this droplet its identity, and it provides a very clear interface for this droplet to be able to say, hey, who am I, and for it to come into life. And since it has that well-defined interface that no third party needs to know of, the image itself can be responsible for its own customization. So now we're completely hands-off on the back end, and this is a wonderful separation of concerns that, since address, actually gives us a lot more flexibility. A very fundamental thing, but easy lesson to be learned. So now that we have metadata, we can decouple the back end. We can put a partition table in the image, and we don't really have to care about the file system details. UFS can write to UFS just fine. The kernel management is just in image. We don't deal with any of the external stuff anymore. SSH keys. This is a little bit of a strange thing. At DigitalOcean, we offer root passwords as a means to access your droplet. When you're running a droplet actively, and it's not necessarily the root passwords, it's the root password reset event that's a little problematic, because that requires the backend to make a modification while the image is in flight. As an organization, we would like to push people towards SSH keys and away from root passwords as much as possible. And on these greenfield images, CoreOS, FreeBSD, we initially do offer it as SSH key only and don't offer that reset root password event. Please use SSH keys, I beg you. And here we are at FreeBSD. I'm just going to dive into how it works. And
so the reason why you don't force keys over just passwords is, I mean, a customer service time issue? I mean,
yeah,
it's just not.
Well, it was initially a product thing.
So when we first launched DigitalOcean, it was meant to be
as easy as possible for it to be accessible to users, and just popping in with a root password seemed friendly at the time, but obviously problematic because we're mainly root passwords, you know. So, but that's something that we're trying to roll back a bit, but that is a part of our product offering. So, but not with FreeBSD.
So FreeBSD, this is essentially how it works. When you press the create button on the create page, the create is scheduled down to a hypervisor with the necessary resources to be able to support the KVM instance. KVM launches, and the droplet acquires an address in the link local space, 169.254 and that /16, so it can query down to metadata and be able to get information about itself. We used a project that we modified called BSD Cloud Init, and we made it so that it could consume the information from our metadata service so that it could, in the middle of the FreeBSD boot process, inject its host name and static network configuration, lay down SSH keys, and grow the file system to the appropriate length. At the boot process, Cloud Init writes into etc rc.digitalocean this dropletid.conf. And the reason that it's key to the droplet ID is because we need to know when it's a new create, as opposed to like a create that was snapshotted. So as opposed to it just being rebooted into its own thing, it can say, okay, I'm still me, I'm still me.
But if this is snapshotted and it comes up with a different ID, obviously it needs to reconfigure itself.
So droplet.conf is similar to that droplet ID, and that is done very early in the boot process, and that is consumed similar to rc.conf or rc.conf local, which is where like you turn on SSHD or like any of the user type configurations happen. It's just injected there, so that's how it's read. And as I said, BSD Cloud Init handles the resizing of the file system so that like we lay down 40 gigs of space, and then BSD Cloud Init expands it so that it uses all of that. Creation of users, the placing of SSH keys, and all of the startup script stuff, configuration bits. So that's kind of the technical side of this and how we arrived here. The other side is actually just kind of getting the organization aligned as far as the engineering organization and the product guys to actually kind of make it happen. We've had a lot of experiments over time with how we drive ourselves as an engineering organization and figure out our priorities, our tooling, all sorts of stuff. And this is just kind of a successful iteration of that process. So what happened was we were given a chunk of time where we essentially flattened out the entire engineering team. Web, SRE, backend guys, we were just all just the engineers. And the product team put forth 7 or 8 projects that we were to spend a couple of weeks on that it just saw as high reward efforts. And we were allowed to self-organize into these teams that the only requirement be
that they be cross-functional across the organization. So pretty much all types of engineers that we have, community people, support, etc.
Consolidated around these. And then we negotiated the scope of the project and the time allotted. For BSD specifically, it was really great to have members of the community team on board while it was being worked on, because we were able to generate the documentation, the articles that we need to support this thing, and part of the bits that kind of make us what we are, being able to support our community as best as I can. And support also was critical because they're the guys in the trenches talking to you guys all the time. They're the ones that see the issues, and their input as well was very valuable to have early on, and we really welcomed that. And it was great because we have a lot of FreeBSD users internally that were just excited about the fact that we were finally getting it together to get this out to you guys. So we got their input as well. With the BSD project, we had essentially well-defined constraints, non-punitive deadline, couple of weeks, and work was going to end, and we would just kind of see where we ended up, essentially experimenting, and a realistic expectation because it was very clear, the negotiation between the product team. And BSD, it's great because the idea of done with FreeBSD is very clear. You have a FreeBSD droplet that does its thing, you know, reacts to our events appropriately, so on and so forth. So having, and just as a side note, that's kind of one of the reasons why we decided to just go FreeBSD alone. I know a lot of you guys are asking for OpenBSD as well. We get it. But this, we kind of want to
see how FreeBSD works in flight, the issues that we come across, so on and so forth. So
we know. And focus. We were allowed to just work on this one thing during this time. A critical element to this is we have a team called Tank, and this is the team that takes one for the team. And essentially they're the team that handles escalation, handles on-call, any pager-duty requests, any of the interrupt-driven stuff, like create a VPN for this user, or there's this weird production thing happening, can you look at this? This is, comes from the gaming world as the, I don't know, heavy guy who takes damage while your party can do whatever you want to do. But just conceptually, as far as organizing ourselves, this is an incredibly valuable thing. And if you have a lot of noise in your environment, having a thing like this is great. So some of the challenges that we hit offering this thing. Talked a bit about the root password thing. Modifying root passwords while droplet in flight is problematic, and we can't exactly serve that via the metadata service because that would be insecure and strange. So we don't really have a great mechanism to manipulate that, and we don't necessarily want to, because we really want to encourage people to use SSH keys on our droplets. And backups. Backups are problematic. What happens when you run a backup on a DigitalOcean droplet is the droplet is in flight. It's actively working, and libvirt comes out under there and then initiates a block copy, which copies off the contents of the file system and then mirrors it up to the point where it's consistent. And then at that point, it has everything that is on disk. But unfortunately, there's stuff in memory that still needs to be flushed to disk. And with FreeBSD, the virt.io stuff, we had access to the network, the storage drivers, the memory ballooning stuff. But we did need a virt.io serial device in order for us, if we wanted to have a guest agent on FreeBSD to say, hey, I'm done with my block copy, please flush, so that we can get the rest of the content on disk, so that we could have a reasonable backup. Since we didn't have that, we tried as hard as we could to actually make this work. And we eventually got it to the point where it was actually, we were mounting the root file system with synchronous writes, which killed performance. And it's really problematic in that regard. So we've actually rolled that back. We're going to make it so that we have the typical vanilla journaling and no async stuff, so we now have decent write performance again. But we're not going to offer backups with FreeBSD as well, just because it isn't consistent what you come down with, just because we can't flush to disk. So that was a challenge, and that gave us the performance issues at launch. But that, as of right now, is fixed, and like as of an hour ago, and you guys are the first guys to know about it. Surprise! So, there was also, so what did we touch? Sorry for wallow text here. But we really tried as best as we can to remain as vanilla as possible. We don't want our fingers in your image as much as we can. So I'll just run through this very quickly. We install curl to go down to metadata to get an idea of what we are. Sudo, because we are accessing the droplet via the FreeBSD user instead of the root user. rsync is for support during the actual image creation process. It's helpful to have there. Avahi auto IPD is the mechanism that brings us up on a link local to query metadata. rping, you'll notice in rc.local that we rping out to the gateway when a droplet is launched. We find that that just helps the MAC address table get in order quickly, so networking essentially comes quicker. It's been helpful. And the Python stuff is to support BSD CloudNet. SSH key is, SSH config is touched just a little bit because you access via the FreeBSD user, and if you try to access it by a root, we just bounce you back. And that's all that is. That's mainly to kind of short circuit support tickets. This is all the boot support stuff that handles the configuration. rc.d.digitalocean is our startup script. And the bootloader bit is so that when you want to console the thing or come into single user mode, you can access it through cloud. And we increase the timeout a bit so that you don't have to very quickly try to get into single user mode when it's initially booting. So that's it. Happy to take any questions. Okay. All right, well, oh, yes, please.
I don't think FreeBSD images run on NYC2 as of now.
Yes, that's right.
Okay. Going back to what I was talking about, the legacy code base that we had that was very tightly coupled, we did a pretty major overhaul of the backend year and a half ago or so that we're still essentially migrating legacy regions in order to be able to support that. You'll find you can't launch FreeBSD in NY1, AMS1, or NY2. And that's just simply because we haven't had an opportunity to convert all the images there. And the metadata service only lives in those refresh regions. MY2 is particularly a bear because it's very big. There is a lot of stuff there. So we need to have the capacity in order to take all of this stuff and then make it this other thing. So we had essentially double all of it to be able to offer that. So yes, you're right. So, and that's essentially why. Anyone else? Yes?
I was actually curious about the organization structure you mentioned when you were working on this. Just your sort of general thoughts on the effectiveness of that, and also you mentioned you had sort of like a tank team. I was curious if you also had like a carry team.
No, we tried to take the metaphor. I tried to roll it back a little bit, but as far as the self-organizing bit goes, there was a lot of great stuff that we got from that bit, but it was an experiment, essentially, as far as flattening out the organization. We did notice that as we continued to self-organize around these teams, it was almost like you were collecting eggs in an Easter basket. And then the iteration, like a couple of times ago, you were still kind of had your feet in this, and your feet in this, and your feet in this. So we're still working on that bit of it. We also recently hired a new CTO that has a lot of strong ideas about how the engineering team should be organized. But Tank is going to remain just because of the utility of it, and it's very effective in reducing noise from project work. And Tank is actually kind of fun because it's just like, it's mayhem a little bit, you know? Like of just all of this operational churn, you're taking all of those interrupts, but at the same time you have you're very close to the cloud, as it were. You're very in tune to what's going on. So I love Tank. Tank is great.
Yes. On that one, we still have on call. So
yes, this is Brian Lyles. He's a software engineer as well.
Okay. So the cool thing is all of our engineers still remain on call. Like I'm not on the Tank project. I'm doing other work, but I'm on call now. So after hours work, I still get my hands dirty. And the cool thing is that when I'm working during the day, I don't really think about on call because I have a group of people. But at night, I take care of it. So it allows you to focus on your work during the day, unless you're on Tank.
Yeah.
And it actually, that's my favorite part. And when I was on it for a little while, I did enjoy it, but Neal did.
Yeah, so I mean, it's not like,
Tank aren't necessarily the whipping boys, as it were, because everyone shares the load, obviously, but it's, I don't know, super effective, yes.
How are you dealing with updates to the base operating system? I mean, are you allowing the user to do binary or source-based updates? Are you patching the images?
As we need to make updates to the image, obviously we pull the latest port stuff. But as far as the community articles, that's the user itself. Like you have full reign over your droplet, essentially.
So I mean, not the port, the base operating system. So like there was a whole bunch of ugly NTP stuff that came out a month ago.
Right. Yeah.
I mean, that would be potentially catastrophic.
Sure. And I mean that once a droplet is launched, that's essentially your responsibility. So, but as far as so in-flight droplets, that is your property. Essentially, that is yours.
But the base images, when there are like significant things like all of the SSL fun that we had for all those months, obviously we'll take care of that, and make sure that the image, whenever there's some serious stuff that comes down, we'll refresh.
What SSL stuff?
What's that? No, you will not make me relive this. Anyone else? Yes.
It's a bit off topic, but you said this is your second boost requested feature.
Yes.
Do you mind sharing what your first?
Yeah, sure. Disk resizing. Essentially, when you do a fast resize, making sure that you have the disk available, and that's actively being worked on as well. So, making that disk bid work. You can find all of our requests at UserVoice, digitalocean.uservoice.com, and you're welcome to scream at the top of your lungs. Let us know what you want. Thank you so much. This was great.